In this video, we're going to have a look at the definition of a radian. I'm not a huge fan of the definition in the textbook, so I've given an alternative one here on the board. Here's a diagram. I've marked an angle on here. It's a circle with radius r, and I've just marked on the arc length. My preferred definition of a radian is it's the ratio of the arc length to the radius. And with that, I think it makes a lot more sense where some of the typical angle sizes come from. So we're going to use this definition to unpick where, a few key angles measured in radians. Okay, you can see I've got 6 circles here on the boards. Here's my first one. I'm just going to draw a sector on here. I've marked a small angle. We're going to say that the circle has radius r, and I'm going to give the circle an arc length of r as well. The question is, how big is this angle? Well, it's the ratio of the arc length to the radius. So, there's the arc length over the radius is 1. There you go. Alright, so we've got an angle of size 1. On to the next circle. I'm going to draw a new sector, slightly bigger. There's my angle. Oh, crikey. Right, and this time the sector is going to have an arc of size 2r. So the arc length is twice the size of the radius. We want to work out the size of the angle. In radians, it's the ratio of the arc length to the radius. 2r over r. It'd be great if I could stop dropping my pens and do maths. There you go. The angle size is 2 radians. Okay. All right. Third angle over here, and we're just gonna change it slightly. This time, I've drawn a semicircle. Again, the radius is r. And the question is, how big is this angle? Well, to know that, really we need the arc length. So we're looking for the length of that arc there. You should know that the circumference of the circle is 2 pi r. That's the distance around the whole thing. So if I want this arc length, which is half the circumference, it's just going to be pi r. Okay, how big's the angle? Ratio of the arc length to the radius. You can probably see it's pi. And this is really why a lot of angles in radians are given in terms of pi. It's because we can measure the circumference, the arc length of a semicircle, the arc length of a quarter of a circle, all in terms of pi. All right, stick with me. This time I want the distance around the whole thing. So 1 full revolution. Again, the radius is r. This is what I'm after. So the question is, what is that distance around the whole circle? We did kind of just talk about it. it's 2 pi r. What's the angle on the inside? It's the ratio of this arc length to the radius, which means this angle in here is 2 pi. And that's why 360 degrees is the same as 2 pi radians. Alright. Okay, 2 more to go, and hopefully this will clear a few things up. Okay, this time I'm looking for this angle in here, which you can see it's 90 degrees, but I want it in radians. I haven't marked on the radius. In fact, we're not even going to use the ratio of the arc length to the radius, because you'll probably be able to get this angle size using some things we've already done. You know that the angle for a semicircle is pi radians. This angle is half of that. So some of you will probably notice straight away that this is actually just pi over 2. Okay, one more. There you go, I've got my angle, it's 60 degrees. The question is how many radians? I'm not going to mark on a radius or an arc length. We're just going to try and use some of the things we've already worked out. Again, you guys know the angles in a semicircle is pi, or the size of the angle is pi radians, or in degrees it's 180 degrees. 60 is a third of 180, so in radians this is a third of pi. We've got it. Okay, so that's the definition of radians, and then just a couple of examples of why many angles are given in terms of pi. When it comes to the exam, it may be the case that you want to convert between degrees and radians and degrees, in which case you can just commit these 2 rules to memory. To go from degrees to radians, oh, the other way around. To go from degrees to radians, times by pi over 180, and to go from radians to degrees, times by 180